Okay, so today we're going to start to look at the difference between expressions and equations, what are solutions, and maybe some solutions of one-step equations. So I'm going to have this be lecture 7A. And what we're going to have to understand is expressions, which is what we've been looking at, have a couple of key features. A, cannot be solved. If you've been saying the word solved about work you've been doing before we get to this section, that's not correct. You've been simplifying. It does begin with an S, and expression begins with E, but equations are going to be the other thing that we're going to look for. Can be simplified. And the results cannot be tested without redoing. So when someone says check your work with an expression, I understand why people sometimes say, but if I got it wrong the first time, I'll probably get it wrong the second time. Because when you're trying to check your work on an expression that you simplified, unless you catch a mistake that you made by looking at it later, which is very difficult to do, you're not going to know that it's wrong. The thing that's new in this class, old is expressions. New, as of today, will be this thing called equations. A, they can be solved. They properly have the word solved. For, if you look at the word solution, it almost has the word solve built into it. They can be solved for a solution. If you have a problem, you want to find a solution. Probably a lot of movies say, they had a problem, I was the solution. The solution can be tested to see if it got the job done perfectly. Okay. Now, because they're not needing to be simplified, they do have an equal sign. So these have no equal sign, have an equal sign. Look at that. Equals an equation. Looks similar. An equation will have an equal sign, but there will be no equal sign in the middle of an expression. There really isn't such a thing as a middle of an expression. But you'll have two sides of the equal sign whenever you have an equation. It could have as little as one digit or the number 0 on one side, but it's got to have something on each side of the equal sign. There are no two sides to the expression. They can get really long, but there's no point where it stops and says, okay, here's something I'm equal to. So that's what an expression is. So they can't be solved, but these can be solved. They can be simplified, okay? But the thing about this is, let's see, B must be worked down to one, usually answer. That's again the solution. You're done with your work if you simplify it all the way. Simplifying, the way we've defined it is, let's get rid of all the parentheses, let's combine all the like terms. If parentheses are still there, it's not simplified. If there are two like terms or more than that are not combined, it's still not simplified. But when those needs are met, you have a simplified expression. And C, the solution must work in the original equation. That means when you get all done peeling away the mystery, finding out what is it that's the one number that works in this equation to make both sides equal, then you can take that number and plug it in everywhere that the variable that it has representing it is. I recommend putting it in with parentheses around it, and the two sides should come to the same target. They should hit the same number. The target is not the key, the solution is the key. The key to this is an equation is solved when both sides, both expressions, reduce to the same value. That's what I call a target. You have a target value that each expression is trying to reach. Sometimes the target is right there for you to see. Sometimes the target is hidden almost till the end of the work. But there's one number that will make both sides hit the same value. And an equation is solved when both expressions reduce to the same value. The expressions are on each side of the equal sign. Notice that an equation has an equal sign, so it can be broken in to two separate expressions. One on the left side, one on the right side. If you're going to find the right solution, you have to find the number that when it goes in for x or whatever letter variable you have, it's going to evaluate and then simplify and work down to a number on the left, and then it has to hit the same number on the right. And if so, you found the solution. If they don't match, no matter how hard you worked and how well you think you did it, you did not find the solution. It has to work in the original equation. Keep this in mind as you take more difficult math courses. You may do some work and think, I found x, but is it the solution? That depends. Does it work in the original equation? What if you're doing a word problem? That's even more intense because a word problem is not a number problem or an equation problem. A word problem, you have to answer the words. So when you do a word problem, you have to take the number that you found and put it back in the words that you're working with to see if it gets the job done. So the original problem in a word problem is not the equation you wrote, it's the words. You have to go all the way to the beginning and make sure your number works. So I want to see, is this value a solution? Let's try like x equals 2 in x plus 5 equals 7. Now this comes down to completing the arithmetic with or without a calculator, but the idea is the number you have is x equals 2. So once you know that 2 is what we're trying to work with, everything else wants to stay the same, but x wants to go in as 2. All right, 2 is in there for x. There's nothing going on in front of it, so I'll put a 1 there. That will free up my x, because 1 times 2, it'll get it out of the parentheses and get me to 2 plus 5, which is 7, to which now we answer to the question, yes. Is, how about this? Y equals negative 4. Okay? In y plus negative 6 equals 10. Question mark. If y equals negative 4, is that the solution? You would go where the y is and you would put in negative 4. Everything else will stay the same. 10 is 10, so that does not need to be redone. No more work has to be done on that. Does that equal 10? Put the 1 in to free up the negative 4. Sometimes there's a number there to do the work, so you don't have to put the 1 in. But the 1 is the reason that negative 4 comes out of the parentheses. And so now 1 times negative 4 is negative 4 plus negative 6. Those two numbers work together. Working together, we got 6 and 4. We get 10. And what kind of 10 do we get? The 6 is stronger than negative. The answer here is no. We don't know what the solution is, but we did try a single attempt of putting in negative 4. Okay? If you thought two negatives add to a positive, we're still working on that. That is something we've got to shake clear of. These work together to get me a 10, but the stronger of the terms is negative, and therefore my result will be negative for this 10. So I'll get negative 10 for the outcome to this. And that's not the same as 10. They can't be kind of close or just a little different. They have to match exactly. So I didn't wind up putting a check on this that said, yes, I checked it, this did work. So that's not going to be it. So let's get something a little tougher here and see if it works. Is A equals 5 a solution to 7A minus 9 equals 24? 7 minus 9 equals question. 24 is locked in. 24 is my target. And what I'm wondering is when my A goes in here as 5, does that work? If it works, the answer is yes. If not, it's no. That's 24, that's my target. 7 times 5 is 35 minus 9, turn it into plus negative. We'll go over here, we'll do 35 minus 9, we'll turn it into 20 and 15. 15 minus 9, one more each gets me 6. 26. No. Is B equals negative 14 a solution? Sometimes they'll say the solution, sometimes they'll say a solution. Kind of depends on what kind of equation you're dealing with, but I'll go with a solution to 7a minus 2 equals negative 100. Now, once you're allowed to use a calculator, of course, go ahead and use the calculator, but algebra requires me to get the a working for me. So I've got my 7, I've got my dash 2, and I got the fact that it's trying to equal negative 100. The a that I'm trying here is to go with negative 14. So you can grab your calculator and do that stuff, but let's see what we've got. 7 times 14 is necessary. So we get our 28, so 2 goes there, 7 times, so we get 98. It's got a single negative, so we're going to get negative 98. We've got our negative 2. We've got our plus. They work together. We got our 98 and our 2. We do get 100. Two negatives don't make a positive. Remember, that's not something we talk about. We have two terms added together to get the 100 for the digits. The stronger term is negative, like the 98, we get that. And this is yes. And the answer is yes. It is the solution, okay? If you tried to go negative 15, it wouldn't work, or negative 13. Even though it's close, it won't work. If you want to be way off, you can try positive 14. But that's also not going to work. It's got the right digits, but if you put in 14, you get 98 minus 2, you get 96. That's not negative 100. So we're looking to see if the solution that they ask us to try is going to work and get us the value that we want. And that's what we have for 7a, but 7b is going to be where we start to look for some of these solutions on our own, doing the work to get them.